It is my pleasure to introduce Professor Naresh Babu. Professor Naresh Babu is very senior professor of statistical quality control and operation research. And he is attached to it ABBS M, that is the Management Institute. And you know that is RPRIT has finished some memorandum of understanding with ABBS related to academic material sharing and writing the book. In this connection, I have requested Professor Naresh Babu to teach you the logistic regression when the data will be categorical in nature, because this course is mainly for training on the categorical data, the multivariate modeling for the categorical data. So you will learn the logistic regression in both bivariate and the multivariate model. So now I am requesting Professor Naresh Babu to deliver the lecture.
Thanks a lot,
Professor
for
Naresh Babu.
Yes, sir. Thanks a lot for your opportunity, sir. Sir, can you allow me to share the screen? Yes, sir. So now I hope you can see the screen, right, sir? Sir, I hope you can see the screen, right?
Yes, sir. It is
Yes.
visible.
Yeah, yes, sir. Right. So thank you for your nice introduction, sir. And I'm very thankful to get an opportunity to work with you. And almost 1.5 year, almost 2 years, I'm working with Dundulan Datta, sir. So that is really a pleasure for me. So coming to the present topic, it is logistic regression. Okay, so first we'll see like what is the meaning of regression, so that we can see the types, and then we can go to logistic regression. So a regression is simply fitting a trend line or something. Suppose if you see X and Y, so if this is X, and usually we call Y is equal to f of X. So this is a function of X, and the points like here, if this is X1 and this is X2 and this is X3 and this is X4, we try to find or fit a trend line, like what is going to be the next unexpected point. Okay, so because we have already, we might be seeing that X1 is this value, X2 is this value, X3 is this value, and X4 is this value. If you try to predict like what is the trend, how the trend is moving here, so that is going to be the regression. Okay, so you cannot have a straight line, but you will have a smooth curve which is flowing in this fashion, and this curve is usually represented as y cap is equal to mx plus c. Okay, so this has been simply derived from a normal equation, y is equal to mx plus c. Okay, so in this, we will see about two variables and two constants. So where x is a independent variable. So x is an independent variable and y is a dependent variable. So y is a dependent variable, and these two will come into in the variable category. And coming to constant categories, we have got two things. One is m and the second one is c. So m is called slope of the equation, and c is the intercept. Okay, Okay, so this is what the basic equation of y is equal to mx plus c, which is usually we call it as a regression line. So basic regression line. It simply tells that y is a function of x. Okay, so when x changes, maybe x can increase or x can decrease. When there is a change in x, y will change. So y will get a change. So y gets changed when x changes. Okay, if you try to see like how far y is changing with respect to x, so that is usually we'll be mentioning with y is equal to mx plus c line. So this is what an introduction for a basic regression. Okay, and since you have already gone through something, we'll see like what is the fit line of that one. Is that best fit or something like that? And here you are going to see something called as the deviation, and error should be as small as we can. Even if error becomes zero, that is going to be good fit model. Okay, and here you might see like what is, suppose if you just take any example like sales of a particular company. Okay, so this is what sales, and you can see advertisement budget. Okay, suppose if you have advertisement ad budget, assume that if your advertisement budget is your X variable and sales is a function of that one. So that is what your sales. Suppose if your advertisement budget is 10 lakh rupees and assume that you are generating a sales of 50 lakhs. And if advertisement budget becomes 15 lakhs, assume that this becomes 70 lakhs. If advertisement budget becomes 20 lakhs, I'm just taking a linear model so that you can understand that in a better manner. So here this might becomes 90 lakhs. So in that case, if I ask you to guess like what will be sales if your advertisement budget is 25, you'll be able to guess some trend here, right? Okay, so there are certain students, and if any student can answer this, I think I'm just able to connect you, and whatever I'm telling, you're able to follow that one. So can I know what is going to be answer here? If your advertisement budget is 10, your sales is coming to be 50 lakhs. If you are increasing 5 lakhs in advertisement budget, your sales has increased by 20 lakhs. Again, you have increased 5 lakhs in your ad budget. It has become 20, it has increased further 20, and it has become 90 lakhs. In this case, if you increase the advertisement budget 5 more lakhs and it becomes 25, what is going to be your sales? I got one person like Shweta G has answered it as 110 lakhs. So fine. So this is what a simple linear regression. Okay. So here you can see X is increasing by 5 points or 5 lakhs or some 5 units, and Y is increasing by 20 units. Okay, so this is what a basic example for a linear regression. Okay, so here you can see one unit of X will make 4 units of change in this one. Okay, because 5 units is making 20 units in change in Y. That means 1 unit will simply make 4 units of change in this one. So this is what a basic example of a simple linear regression. Suppose if you, this is what a positive function. Okay, so because I'm just telling, so X is 10, 15, 20, 25, and you can see 90, 50, 70, 90, and 110. So this is a positive, having a positive slope here. Okay, slope here it is going to be delta y divided by delta x. So here you see there is a change in y with respect to there is change in x. Okay, where what is the rate of change? Simply slope is equal to rate of change in dependent variable. So change in dependent variable with respect to rate of change in independent variable. Okay, so this is what we have seen, basically a slope. Okay, if there is an intercept or an error term, is that here I can see simply everything is going like that. Okay, so plus 5, plus 5, plus 5, which is leading to plus 20, plus 20, plus 20. Sometimes you might not get this accurately or exact. So such functions might be called as, might be having something called as an intercept. So in that case, y is equal to mx plus a constant also will be there in that case. Okay, suppose if you take some kind of a function where you can see that in a negative sloping curve also. Okay, suppose if you are giving a training for 5 hours, just assume that this is your training hours and this is your errors, the errors that people are making. So when the people are giving 5 hours training, assume that people are making 200 errors. If the training has made it 8 hours, so this errors, assume that it has come to 160. So if training has become 11 hours, assume that this has become 120. If training has become 14 hours, so your errors might have come to 80. So in that case, if I just ask you like what is going to be the number of errors if you give training of 17 hours? So can anyone just give answer like earlier Shweta ji has given? So now you see this is some kind of a decreasing function where when you are increasing value of x, the y factor, which is errors. So here in x-axis, I can take the number of hours of training. So number of hours of training. So when this is increasing, it might be 5, 6, 7, 8, 10, 20, something, it is increasing like that. When it is 5, the number of errors made by people are at 200. When it is 8, the number of errors made by people are 160. When it is 11, the number of errors made by people are 120. When it is 14, it has come to 80. So again, I got some answer. I'll just check when some person has responded. So this is 40 errors. Okay, the errors that you are making will come down. So this is a downward sloping curve in that m is okay. So what is rate of change in y? That is errors. So rate of change in errors divided by rate of change in training hours. So this is what another slope, which is usually called as a downward sloping curve. So this is a forward or a positive sloping curve, and this is the second one is I'm talking about a downward sloping curve. In that case also, so y is equal to mx plus c. So this is what a basic equation of any linear regression. Okay. If you just try here, you're talking about only one variable. Okay. So, and usually, since we might have already studied in mathematics that slope of any equation is equal to y2 minus y1 divided by x2 minus x1. So here, if you have only two points, like this is talking about a line which is having only 2 points, x1 comma y1, x2 comma y2. So this is what the basic equation that we see about the slope. Okay, when we have only 2 points, but here you can see there are multiple points, right? So I have taken a multiple points here. So in that case, I cannot simply make it as I cannot simply make x2 y2 minus y1 divided by x2 minus x1. So in that case, I'll just see m is equal to delta y divided by delta x into correlation. I hope you have already got some basic idea of correlation, because if you are studying about regression, probably you might have come across something called as correlation. Okay, so correlation is simply you will see about covariance of x comma y divided by standard deviation of x into standard deviation of y. Okay, so this is what your correlation. So correlation is the relation between two variables, and especially x and y. So with this, you are going to get your slope as well as covariance. So using that, you fit a regression line. So if you have multiple equations, so then y cap is equal to mx bar plus c. So this is what you are going to see when we have multiple points. Okay, so if we have multiple points, so you are going to get a regression equation like this. If you have only 2 points, you can simply mention y is equal to mx plus c, where slope is y2 minus y1 divided by x2 minus x1. But if you have multiple points, you cannot have one slope specifically. So for that, you'll be just trying to find out delta y divided by delta x. Okay, or sometimes, so this is also represented as m is equal to standard deviation of y divided by standard deviation of x into correlation. where correlation coefficient R is found with the help of covariance of x comma y divided by standard deviation of x into standard deviation of y. So this is what a basic linear regression. Okay. So the present topic is talking about today we are going to see something called as logistic regression. Okay. So there is a difference between linear regression and logistic regression. So in linear regression, you can see this is a metric variable. So X, so independent variable is in numbers. And this also is like the dependent variable is also in numbers. Okay. So if X comma Y, X variable comma Y variable are metric variables. So metric variables or quantitative variables. I hope you have already seen like quantitative variable, qualitative variable, categorical variable. If both are quantitative variables, so then we can use this linear regression. Okay, the linear regression can be used when x comma independent variable and dependent variable are quantitative in nature. Suppose in some cases like the dependent variable. Okay, so in some cases the dependent variable can become categorical variable. So dependent variable might be a categorical variable. Okay, like yes or no. Okay, so in this case, you are not predicting any number. So here, as Shweta has predicted, here it is going to be 110. So this she has predicted because she knows like what is change in X and what is the change that has been reflected in Y. Similarly, in the number of hours training, so she has calculated. So this is increasing +3 and this is decreasing by 40. So y variable is decreasing by 40. So this is what she has seen and she has calculated and told simply here also you are going to get as 40 errors. So 40 errors because it is a metric in nature, quantitative in nature, and you can simply find out what is going to be the next value here. So this is simply talking about only one independent variable, one dependent variable. So in this case, you might have multi-variable also. So multiple independent variables also can be possible. If we have multiple independent variables, so then it is represented as multivariate analysis. Okay, so multivariate analysis means you are trying to predict something with the help of more than one independent variable. Okay, suppose if you see the number of cars sold. Okay, so number of cars sold in 2021, 2022, 2023. So assume that this is 1.8 lakhs by one company. So the same company could able to sell 1.9 lakhs and here it is 2.21 lakhs. If you see like why, like if you want to predict what is going to be the overall sales in 2024, so if you want to predict this number, you might have to consider many variables. So tax rate should be considered. Okay, income of the people should be considered. Okay, and any benefits provided by the company by the government should be considered. Benefits provided by the company should be considered. So if you have consider, this is talking about x1 variable, this is talking about x2 variable, this is talking about x3 variable, this is talking about x4 variable. If you have 4 independent variables which are affecting the sales of a particular company or particular phenomena, so then that is called as a multivariate analysis. Guys, is that fine or am I going fast or something which is not related to you? Because there are 3 to 4 students. So 3 students, Shweta ji, Soma ji, and Sobarna. Okay. Can I just have like, are you able to follow or anything which is not clear or any doubt something? If you have any doubts, you can just put that in chat, or if you feel comfortable, like this is going okay, fine, I can simply go to the next, like the present topic. If you feel
Achha, sir,
anything,
please you tell them
yes,
that is
sir.
one unit change in X variable,
Okay.
how another unit of change occurs in the dependent variable.
Okay, okay, sir. Okay, sir. Fine, sir. So it is understandable, but a little bit slower would be better. So thank you, Shwetaji. I'll try to be a better, I'll try to slow somewhat. So here, if you see the first thing, okay, so let me take the same example. 1 minute, I'll just try to erase this completely. Okay, so fine. Suppose there is X variable, and X variable is the advertisement budget. Like otherwise, you can take the number of hours studied. Number of hours studied. So assume that you are studying 1 hour and you are getting some 45 marks. And if you are studying 2 hours, assume that you are getting a marks of something 55. Suppose you study 3 hours, you might be, so this is just a tentative data. So if you study 4 hours, assume that 75. So here, this is a very basic example, like for every change in 1 unit of X, okay, for every change in 1 unit of X, you can see change in 10 units of Y. Okay, so if X changes by 1 unit, Y is changing by 10 units. So this is what the slope here. Okay, so rate of, if you see rate of change in Y divided by rate of change in X, that is equal to, if you take any 2 points, okay, if you consider these 2 points, I'm just trying to find out 55 minus 45. This is what the rate of change in Y divided by rate of change in X. So X2 minus X1. So this is going to be 10 divided by 1, which is equal to 10. So this is what the case of slope here. Okay. And I have taken very linear equation so that the change is reflected as same. Okay, if I take the point x2 and x3 and y2 and y3, so slope here is equal to y3 is 65 and y2 is 55 divided by x3 is 3 and x2 is 2. So this gives me, so 10 divided by 1, which is equal to 10. So for every 1 unit of change here, for all 1 unit of change in X, 1 unit of change in X results in 10 units of change in Y. So 10 units of change in Y. So based on that, you can predict what is going to be that one. Okay. Even if you see the simple cricket scores. Okay. So for every for 10 overs, a batsman have scored 100 runs. Okay. And we have totally 20 overs. So 20 overs, what is going to be the score for after 20 overs? It is simply double the score. It is going to be 200 runs. Okay. So this is what with the present run rate. So this is what a basic example of a linear regression. Okay. So here you are trying to simply find out what will be a rate of change in Y with respect to rate of change in X. Okay. So here you can simply find out this rate of change because both are metric in nature, both are quantitative in nature. Suppose if you're talking about a particular thing, I'm just trying to take one more slide here. Yeah, so yeah, so here if you just try to see what exactly the other variable. Okay, so basically the representation of variables will be something like here. So qualitative variables and quantitative variables. So assume that we are dealing with two types of variables. Okay, here you might see that nominal variable, ordinal variable, and interval scale, ratio scale. Okay, so mostly the regression can be useful for this and this because we are talking about quantitative variables. Okay, so if it is 10 to 20, what is going to be the 20 to 30? Okay, so 30 to 40, what is going to be the output something? And ratio scale, if I change X by 10 units, what is going to be the change in Y? Okay. If advertisement budget is changed, what is going to be the change in sales? Or if number of training hours has been changed, if number of training hours, if I increase, what is going to be the errors or productivity? Because you are checking one number, you are trying to find out one number with respect to other number. Suppose in this case, if you want to find out or predict something here, okay, assume that a person went to some doctor. Okay, so a person went to some doctor. Now, doctor will diagnose him and he has to check whether this person has got any disease or not. Okay, either that person has got disease or there is no disease. So, in that case, he will check the medical record of this particular guy. So maybe he can check like what is age of that person, because there are certain diseases which comes along with age. Okay, and so what is the food habits? So what is the food habits? So in food habits, maybe he is a vegetarian or he might be a non-vegetarian, or he might be taking less spicy food, or he might be taking more spicy food. Okay. So what, and exercise related habits. So physical exercise related habits. So he'll do exercise, he will not do exercise. Okay. Next, it might be smoking related habits. Okay, smoking or alcohol, something. So either he might be a no smoker or he might be a smoker. So if these are the things, it is not telling about anything. Age is a, though it is a number, it is just a number which will not predict anything, which will not be useful to find out like whether he is having a disease or not. Okay, though the person's age is more, if the person is having very good food habits, so he'll eat less spicy food and he'll do exercise every day, and he's a non-smoker, the chances of getting disease is going to be very, very less. Okay, so very less if he follows a very good lifestyle pattern. Okay, suppose if that person is not having a proper food habits. Okay, food habits. He takes more spicy food, more oily food, and he is completely a non-vegetarian, and he will not do any physical exercise, and he is a smoker or alcoholic. So these symptoms will make maximum chances for getting to be disease. If you want to analyze this kind of this type of situation, so then we are going to see this logistic regression, because if you see this age and food habits and exercise related habits and smoking related habits and some other daily routine patterns will come into nominal or ordinal variable categories. So in such categories, if you want to predict like what is going to be the position of that person, is he a healthy person or a not healthy person? Okay, the second example that you can take for that is voting pattern. Okay, so voting pattern. So many people will try to give a campaigns. You need to identify that voter, whether that person will vote or he will not vote. Okay, so probably for taking this decision, he might think many things like what is the income that he is getting, what is the tax position, and what is the roads position, pollution related, whether he is getting right support from the government or not. He'll think many aspects. All those are categorical in nature. So all those are categorical in nature. And even if any particular company wants to predict whether he'll vote or don't vote, so there will be a lot of variables which will be considered. So all those will be categorical in nature. Okay. So this is what a logistic regression. So linear regression, it is simply like predicting a number. Okay. If you are predicting a number, a metric value, predicting a number or a metric value using some other numbers, So you can simply use your linear regression. So linear regression, maybe with single variable or multivariate regression. Okay. But if you're trying to predict an outcome. So I'm not mentioning it as some value, the predicting an outcome by using categorical value, so categorical data or metric data. So we might use some metric data also to find out an outcome, whether it is going to be successful or failure. So for such scenarios, we are going to use your logistic regression. So is that clear, guys? I think one person is there. Fine. So is that fine? The basic introduction of logistics regression. Is that clear, guys? Oh, there are two students, Shwetaji and Somalji. Is that clear or any doubts? If you have any doubts, I'll try to solve that. Otherwise, I'll move to the topic. So, sir has asked me to tell something basics about regression, then start the logistic regression because you might have already come across all these things. Is that clear, ma'am?
Sir, may you get one more example?
Yeah, so you want one more example? Fine. So we can see, okay, whether the match, there are two possibilities for matches. Either you can win or you can lose or you can lose the match. Okay. So for winning or losing, there might be multiple reasons for that. Okay. You will see the batting position. Okay. You will see the bowling position. You will see the fielding position. Okay. You will see how many errors that we have made. Okay. If you see, the batting can be considered as very good or something. So this is going to be one ordinal variable. Okay. And bowling also may be very good, bad, excellent something. Fielding might be very good, average, something like that. Errors. So 5 errors you have made, 6 errors, 6 catches you have missed. So you are not able to catch ball correctly. You are not able to throw correctly. So these are 3 to 4 variables which might lead to either win or lose the match. Okay. If you do everything perfectly, batting is very good, bowling is very good, fielding is very good, errors 0, then the chances of winning will be very high. Suppose you are poor in bowling, you are poor in batting, only in fielding you might have done well. The chances of losing is more. Okay, so that is what you are going to see in logistic regression. Because if it is a linear regression, you can simply even you have guessed, like if there is a 5 increase in x, 5 increase in x will lead to 10 increase in y or 10 decrease in y. So this is what a linear regression. So linear regression will simply use one number to predict other number. Okay. So, but logistic regression will not use number to predict a number. And usually the predicted values will be an outcome. Okay. So maybe you can tell that whether this person has a disease or no disease. Okay. The person will vote or he don't vote. Whether you will win or lose, whether you will pass or you will fail. So these are the things where you are going to get only 2 outcomes. So one may be favorable outcome, the second may be unfavorable outcome. Okay, so this is what the basic introduction, and anyhow we are going to see some more things. And so with this, I can think I can start my today's topic. Logistic regression is a statistical model used for binary classification tasks. This is very important. Okay. As I told, either you can pass or you can fail. So there are only 2 options, binary options, either 1 or 2. Okay. Either you will vote or you don't vote to a particular party. Okay. So either in match you may win or you may lose. Okay. So you might go to a movie or you will don't go to a movie. Okay. Or you can see that either it will rain today or there is no rain. Okay. So these are the only 2 possibilities. to predict this sort of binary classification or categorical outcome, we are going to use your logistic regression. Okay. So here where the ultimate goal is to predict one of two possible outcomes. Okay. So this person might be win or lose. This person might be pass or fail. This person might go to movie or he will not go to movie. So there are multiple options, there are multiple variables, but your outcomes is going to be only two. Okay. So plus or minus. So if it is plus, why? What is the reason? If it is minus, what is the reason? So this is called as logistic regression. It belongs to generalized linear models. So this if you are learning R language, you might have come up with something called as LM. Okay. So there is a function in R which talks about LM and something. We'll give a lot of inputs, like what are the inputs, which will frame a model. And logistic regression also is one of the family members of generalized linear models. Okay. So it is an extension where you are predicting a categorical output. Okay. So this can be used in usually machine learning or medicine or finance. Okay. So someone asked about a specific example that in finance, you will tell that whether the person, okay, so a person has taken a loan. Okay, whether he'll pay a loan or he might become a defaulter. Okay, so defaulter. So there are two options. Either if he is perfect in his managing in finance, he'll pay the loan. If he is not perfect in managing the loans, he'll become a defaulter and he'll not pay the loan. So this is one more example which is related to finance. Okay, in social sciences, suppose in marketing, if you just take a marketing case, either you will purchase a product or you don't purchase a product. Okay, so when do you purchase a product? Suppose if you like the product, definitely you can purchase that one. If you like the price, you can purchase that one. If delivery is perfect, then you may purchase that one. So if you find something relevant, you will take a decision favorable to the company. If you are not comfortable with the company or the price or the product, so you will not take that one. So this is one more example related to the marketing. Okay. So next, in some of the business applications, we may come across a dependent variable. So that's what a dependent variable, Y, is a function of some categorical variables. So categorically in nature. Linear regression cannot be used because, as we have already discussed, linear regression uses both numbers. Okay. Y is a number, X is also a number. So if you just take any function as y is equal to fx, function of x. So here, if x is a number or y is a number, if both are numbers, then you can use safely linear regression. Okay, y is equal to f of x. Usually this will not be a number. So it is a categorical in nature. So this is a categorical variable like pass or fail, yes or no, pay or not pay. And even in this x, it may be a number or a categorical variable. So if any of these two will make to take a decision on categorical variable, so that is called as a logistic regression. Okay, so this is logistic regression. Okay, so here some more definition is, so logistic regression is a technique which enables a regression model to predict the probability of a particular categorical response. Okay, so remember this word is heart of your logistic regression. Okay, so we are just going to predict the probability. With that probability, you will take a decision whether this will go this way or that way. So this is a positive thing, this is a negative thing. What is the probability of this particular value coming to be either this or coming to be to this side? Okay, so this is what that will. And what is the range of probability? I hope you know probability will be between 0 and 10. So 0 and 1. Okay, so probability might be either 0, 0.5, 0.2, 0.3, something up to maximum 1. So depending upon this probability, you will tell whether this will be either positive outcome or a negative outcome. Either the politician will win or lose, or the customer will purchase or not purchase, or the person who has taken loan will pay or he'll become a defaulter. Is that clear, ma'ams?
Yes, yes, sir. Thank you.
Fine. So thanks a lot. So now here, if you see the characteristics of logistic regression, yes, it is a binary dependent variable. So binary means either it's going to be 0 or 1, yes or no. Okay, either disease or no disease. So you can see here a marketing case whether you are going to purchase the product or not purchase the product. So here, in case of voting, you may vote or you may not vote. Okay, so in health condition, your health is good or health is not good, or your and you are going to say yes or you might tell no. So there are only two variables. Okay, so that is what either success or failure, yes or no, correct or incorrect. Okay, so diseased or not diseased, web page visitor. So you can if you take one other marketing example, you might be clicking many things. Okay, so you will check like what is today's news. So if you just click that one, you may get an advertisement. Okay, what is the probability that a person will check that ad, whether he'll click that ad or simply he'll close that ad and he'll go to that movie? So that also depends upon his day-to-day activities. So day-to-day activities, suppose if the person is continuously watching advertisements and then he's going to his regular web page, so the chances of that sort of person buying a product will be more. Okay, but there are certain people who will simply avoid that and they'll simply go to their business or their web page or activity. Those in that cases, the probability of sales also will be somewhat less. So that is what this one. Okay, so whether that person will click ad or not click ad, and the finance, either he will be default or he will not be a default. So these are the binary variables in nature. And the predictor variable can be categorical in nature. Okay, so in most of the cases, the predictor variable, like the dependent variable. So in y is equal to fx something. So this is a dependent variable. So this dependent variable is called as a predictor variable. That predictor variable will be mostly categorical in nature. It is not going to be a number, it is going to be a category. Okay, yes category, no category, default category, not default category, diseased category or healthy category, something like that. Okay, and we are going to use something called logic function, because logistic regression will talk about a logic function which talks about a particular odds. Okay, so that is favorable condition divided by unfavorable condition. So this is what called as logic function, and it usually also called as the odds number or odds function. Okay, so this is what called as logic function or odds function. We are going to use probability for this, then we are going to get our final outcome, whether this person will purchase our product or not purchase. And there are certain assumptions related to that. The output will be either yes or no, and mostly the data distribution will be a linearity is there, independence of this value, and mostly no outliers. So this is what normal regression related assumptions, and mostly that will follow here also. But only difference is the binary output. But in linear regression, you will have n number of variables, and it's going to be the value is going to be minus infinity to plus infinity in the case of linear regression. But in logistic regression, you are going to get either 0 or 1. Okay, or in between 0 and 1. So when to use the logistic regression? If we have only two outcomes, then we have to use that one. And important thing, as I told, probability estimates. So that is what called as log odds. So logic function will use something called as log odds. So this is simply found out with the help of this formula: favorable outcomes divided by unfavorable outcomes. So this is called as odds And so if you find out probability of that odds, you are going to get your probability estimates. And non-linear boundaries. So logistic regression can handle non-linear data. So if I just tell X as 5, 10, 15, 20, and Y as 100, 200, 300, 400, you can see some linearity here as well as here. So plus 5, plus 5, plus 5. So here you can see plus 100, 100. All the changes are somewhat linear. Okay. But if there is something called as excess non-linear data. Okay. So I'm just telling 5, 18, 39, 86. Here assume it is 100, 142. So 194. So 236. If can you predict what is the next number? Definitely we cannot predict what is this and what is this. Okay. Suppose even if there is something here as 149, so there is no linearity here. So here it is plus 13. Here it is plus 21. Here it is some plus 50 or 47. So here the change is not linear. Similarly, here it is plus 42. Here this is plus 40, so 52. Here it is plus 46. So 48 or something. Here there is no linearity. Even in these cases, you can use your logistic regression. Okay. And understanding impact. So understanding impact means you need to try whether the voter is in favor of party X or party Y. If you want to understand the pulse of voter, or if you want to understand the position of heart, okay, so maybe heart disease related, or if you want to understand the position of buyer, okay, so under such circumstances, if you want to understand something, so very important thing, if you want to understand something, the consumer behavior, okay, so there is a big subject called as consumer behavior. If you want to understand consumer behavior, definitely you have to use logistic regression. Okay, most of the people feel consumer behavior is simply a marketing subject, you can do anything. But the irony is that if you want to understand consumer behavior perfectly with the data, definitely you should be an analytics person who is comfortable using the logistic regression, because to understand consumer behavior, there might be multiple factors. Suppose if as a consumer, I am thinking like I'll think about price of a product. I'll think about the quality of the product. Okay. I may think about the delivery position. Okay. So the delivery position. So today I have, yesterday I have ordered one laptop, and so today he just called me and told that I'll not be able to deliver at your point, and can you just come to some point and correct that one? Then I said, then I have rejected the product. Okay. Because the concept of online purchase or online marketing is simply you want more convenience to get your product at your doorsteps. If you are not getting that one, obviously you will reject that. And my review for that is going to be that company is going to be definitely negative. Maybe it is a Flipkart or HP. So this is what one more factor. So not only price, we need to check the quality, and delivery status also will allow to take a decision to purchase or not to purchase. So this is very, very important. Okay. How many people rejected product because of delivery status? How many people rejected product because of quality status? How many people rejected because of price status? How many people rejected because of warranty? So there might be many things. If you are trying to check all these things, if you are understanding that one, so that in that case you are going to use your logistic regression. Okay. So next, as I told, application areas, medical diagnosis, you are trying to predict whether this person might have a disease or he might be healthy. Okay. If he is healthy, maybe I can consider it as a positive sign. If he is disease, maybe it is going to be a negative symptom. Okay. And finance. In terms of finance, so this particular person has taken a loan, whether she will repay the loan to the bank. Okay. So you can see she has taken certain loans, and she may pay to that bank. Okay. So she may repay, or she may become a defaulter. Okay. So she may become a default. So there is a possibility. So this is another thing that we have to think. And come to the marketing thing. So marketing, this person because this person is thinking multiple aspects before taking a decision. So finally, he'll make one decision, either to purchase or to reject the product. Okay. So before that, he'll think many things, and our duty as analysts is to check by giving inputs to a particular system whether this person is going to purchase the product or not. So that is what we are going to see here. And the credit scoring. So you might have seen something called as a CIBIL score. Okay, the CIBIL score, usually you might have seen something called CRISIL also. I'm sure, ma'am, because always I'm just talking. There are two learners for me today, so notable learners. So I hope you might have come across CIBIL and CRISIL, right?
Yes, sir.
Yeah, if you are like the people, if you are not comfortable with the sound things, probably you can put a text message in chat, because I just wanted you to involve in the class. It's nothing more than not to test your knowledge, but to make you more involved. If you are not aware of that one, you can just tell, so that I'll try to explain that. Okay, because I should not be in a position opinion that I am just talking and whatever I'm talking, you are understanding that. So that CIBIL score and CIBIL score, it should be 300 to 700. They have got some ranges. Okay, if it is 300 to 700, somewhat okay. If it is less than 300, it is very danger, and the chances for that person to go for default is more. If it is more than 700, he is a good for issuing the loan. Okay, so before issuing a loan, you need to check that one. So this comes to be some kind of interval data. Okay, so if you are talking about interval data, maybe you can use logistic regression depending upon other variables also. So this is called as that credit scoring and credit rating. Okay, so credit worthiness will be told, and the CRISIL ratings might have seen A plus, double A plus, triple A plus, A triple plus something. So CRISIL will give ratings like that. If you have triple A plus or A triple plus, it's going to be a very good buy. So you can blindly believe that company, because it is that scoring rating of that company is very good. So there are certain companies like B minus, so C, D. So if any company got this C or D, so this D rating is also already a default one. There is no guarantee for the money that you are investing in that particular company. So these are applications of your logistic regression. Okay. So now you see here there are different independent variables. So this is one independent variable. This is other independent variable. This is other independent variable. Okay. Assume that you are talking about age, uh, working conditions, and amount. So this might make you as a healthy person or a diseased person. Okay, so this is what a dependent variable. So dependent variable is also called as criterion, where independent variable is also called as a predictor. So this is what we have seen even in second slide. Okay, in second slide I've just mentioned. So when your independent variables are categorical, so if these are categorical, so then linear regression will not be able to give answer for our expectation, because here also you are not getting any number metric variable. So output also is going to be either 0 or 1, which is usually called as a nominal variable. It's a nominal number. Okay, so it just tells about some number. Okay, so and here you are going to get an outcome either fail or pass, correct or incorrect. Okay, so maybe you can get dots here and dots here. If you remember the linear regression which I have mentioned in the earlier case, so as it is talking about x1, x2, x3, x4, x5, you will get a particular line from here to here. Okay, so this is what a predicted or projected line. But in linear logistic regression, we'll get only the dots here or dots here. And if you may see a function like this one. Okay, so this is usually represented as S curve. So if you see any textbooks, you will see that as S curve because your output will be lying either here or lying either here. So this here will be decided with the help of something called as cutoff rate. Okay. So in default, maybe I hope you are thorough with SPSS. In SPSS, the default cutoff rate is 0.5. Okay. So the variables which gets the value with the function. So the function is going to be somewhat critical, but there is nothing to worry. So once I complete this explanation, I'll show how this logistic regression function will be created and it will be calculating the value. So in SPSS, the function will have a default value 0.5. By using this sort of calculation, if you get a predictor value as 0.38, this will be automatically treated as 0. If your predicted value is going to be 0.76, okay, so then this will be automatically treated as 1. That means the value which is less than 0.5 will be automatically treated as 0. The value which is more than 0.5 will be automatically treated as 1. Because we have to identify the probability, and the probability which is less than 0.5 will be straight away considered as 0. The probability which is more than 0.5 will be considered as 1. Okay, so this is what the things here. Okay, so this talks about the logistic regression, the value, and here I'm not talking anything about this. So once we see the differences between linear and logistic regression, then we'll see how this function is derived and what is the probability associated with this one. Okay. So linear regression is used for regression problems, but logistic regression will be used for classification problems. As I mentioned, this is widely useful for machine learning. Okay. So you have to classify whether this is right or wrong. Okay. So either is this right or wrong? Is this correct or incorrect? Is this pass or is it fail? Is it good or is it bad? You are going to classify the total number of observations into either this group or this group. So for that classification, you are going to use your logistic regression. And linear regression is used to predict a continuous variable. Okay. I hope you are aware of the meaning of continuous variable. Can I assume like that, ma'am? Can anyone give example for a continuous variable? It's just a refresher session for you. So because linear regression will be useful for predicting a continuous variable. What is a continuous variable? And can I have an example for any continuous variable? Because you will be seeing many variables daily. Anyone? Okay, so good. I've got some response in chat. Example is height. So good. Shweta ma'am has mentioned example is height. Okay, so and time, good. There is some other, what is opposite for this continuous variable? So in variables, one more categorization is discrete variable and continuous variable. Okay, coming to this discrete variable, you can count the variable. Okay, continuous variable, you will measure the variable. Okay, that means as you have mentioned height and time. So both have given very good examples. So height of a person, weight of a person, or time. So these two are continuous variable. We can measure that, but we cannot count that one. Okay. Height 2.3, 2.34, so 5.67. So it continues and we It usually has a decimal points. Okay. And come to the discrete variable, example is number of students attending the class. Okay. I can count 1%, 2%, 3%. If you are counting any particular variable, so then that becomes a discrete variable. And if you are measuring that one, if I'm not able to count, but if I measure only a particular entity, so then that becomes a continuous variable. Okay. And linear regression will be used for predicting that one. So here you can predict. So as x-axis, independent variable, it is changing. X-axis, maybe ad budget. Okay. Advertisement budget. When I increase my advertisement budget, my sales is increasing. So I am assuming y-axis as sales. So you might not have exactly a straight line, but you might get a variable here, second variable, third variable, fourth variable, fifth variable, sixth variable, and you might fit a regression line, okay, using these values. So that is what linear regression. But coming to the logistic regression, as I mentioned, it is used to predict a categorical outcome variable. So this is what I mentioned. Outcome, it might be, so this outcome might be right or wrong. Okay, so right or wrong, correct or incorrect, pass or fail. Maybe you will purchase or don't purchase. So you're going to predict a categorical outcome. It is not a number that you are predicting. Okay, so whatever the number that you are predicting is just a probability. Probability of purchasing, probability of winning, probability of raining, probability of voting. So this is just a probability. So it is going to be a categorical variable. And so this is more sensitive to outliers. Okay. I hope you know the meaning of an outlier, right? Ma'am, I hope you know the meaning of outliers. And usually box and whisker plots will tell about that outliers. Okay. If any particular observation is falling Q1, Q2, Q3, and Q4 and Q0. Okay. So this is called as a 5-point summary. And if your any particular variable or data point is falling in this category on this category, then we call it as an outlier. Otherwise, there is no outlier. But this particular thing, so this particular linear regression is more prone towards these outliers. If outliers are there, the value of prediction, the predictor variable will automatically change. Okay, so dependent variable will change if you have any particular outlier. But logistic regression will not be affected with the outliers. Okay, one of the assumptions says like it will have very less outliers, but even if outlier is there, that will not be affected. You can see here either you will be having values in this category or the values will be in this category. Okay, so the values will be in this category. You can see an S curve. Okay, so this is what an S curve which you are going to see in logistic regression. And whatever the cutoff value, as I told, cutoff value will be usually 0.5. If you get any value which is less than 0.5, we are going to get outcome as 0. If you get any value as more than 0.5, we are going to get outcome as 1. So it is going to be always an inverted S curve. Okay. And coming to this one, a linear regression assumes a linear relation between dependent and independent variable. But logistic regression will not assume any linear relationship between dependent and independent, because most of the cases your dependent variable is going to be an outcome or a probability, but not a metric in nature. So you cannot have one number. So one is a number, maybe X is a number, Y is a category. So we can never have any linear relationship between with one number and one nominal or categorical variable. Okay, assumes normally distributed errors. Okay, so this is about a next level or research oriented related things which will talk about that error distribution. And but here they will not assume it to be normally distributed. Okay, errors will not be assuming to be this one. And this applicable for forecasting something, effect analysis. So if you are trying to find out, even weather forecasting can be done with the help of linear regression, but logistic regression will be useful for binary classification. Okay, yes or no, fine or not fine, healthy or not healthy. For that category, it is not for forecasting, it is classification. And is linear regression assumes homoscedasticity, that is constant variance of errors. So this is a connection point for this one. So they will assume, linear regression will assume that your errors are not linearly, your errors are constant variance, having constant variance. And coming to the logistic regression, it will not assume homoscedasticity. Okay, so that constant variance of errors will not be assumed. And coming to the next one, linear regression is usually used for best fit line. So because as I already mentioned in the left side, so this is what talks about linear regression. You can see a best fit line using the data points. But our logistic regression is going to be an inverted S curve, which is shown on the right side. Okay. On the right side, I've mentioned something. So this is what your linear logistic regression. It is not a fit line. It is going to be S curve. And the last one, this method is used to be ordinary least squares method for linear regression, but maximum likelihood is going to be the method used for logistic regression. So the maximum likelihood is, as I already mentioned, as if a cutoff rate is less than 0.5, it assumes the outcome to be 0. If cutoff rate is more than more than that cutoff rate 0.5, it assumes to be 1. So though your probability is going to be probability 0.82, it will assume it to be the outcome will be like this, because it is the maximum likelihood of that outcome. If your probability is 0.38, so as this is less than 0.5, it assumes the outcome to be 0. Okay, so this is how it classifies the overall thing. Okay, if with the help of some nature, if you get a probability of a person who has taken loan as 0.38, okay, so there is a person who has taken loan, okay, and you have studied his age pattern, his income pattern, his day-to-day expenses pattern, his loan pattern. So after studying all these things, you'll fit a particular line, which I have shown in the last category, f of, the probability is 1 by 1 plus e power minus z. With this calculation, if the value is coming to be less than, value is coming to be 0.38, then we'll tell that, okay, so he might be a defaulter. Okay. If by calculation of all these values, if the value is coming to be 0.82, then you can tell that he might not be a defaulter, like that. So here you are going to classify with the help of maximum likelihood method. Okay, so mostly this person is going to be in this category, or that person can be in this category. So this is a default category. This is a genuine category or repayment category. So based upon the probability which you got, you'll be classifying this person to here or to this category. Okay, so this is what differences between linear regression and logistic regression. Is that clear, ma'am? If it is clear, I'll move to the next slide. Is that fine, or anyone has got any doubt? Any doubt, or can I just assume you're comfortable here? Okay, so I got a message. I'll check what is that one. Okay, so Shitaji has mentioned it is clear. So thank you. So next, so this is what I just wanted to tell. Suppose a person went to a doctor for some heart checkup. Okay, so now you see there are to check the heart state. You might have gender might be one of the reasons to get something. Okay, so heart related issues. And smoking, the smoking habit can cause heart problem or may not cause heart problems. Okay. Now we are going to see a database of certain things which tells about like what is age of a person, what is gender of that person, what is smoking status of that person. Depending upon that, whether he might have a health problem or not. Okay. So that is what your dependent variable, or that is called as a criteria. Okay. So dependent variable or criteria. So dependent variable, it might be disease, yes or no. Okay, so if he has disease, it might be yes. If he don't have disease, it will give the outcome as no. Okay, so here no will be coded as 0 and yes will be coded as 1. Okay, if you get the probability to be closer to 1, so then it shows that this is it, that person has got some disease. If you get probability which is closer to 0 or somewhat nearer to 0, so then you can tell that this person doesn't have any disease. Is he need not to be worried. Okay, so now if you see a normal regression equation, so this is what a normal regression equation which talks about y cap is equal to b1x1 plus b2x2 plus b3x3 up to so on bk plus a. Okay, so here all this x1 is one independent variable, x2 is another independent variable, s3 is the third independent variable, and this b1, b2, b3 are coefficients of that independent variables. Okay, and a is something called as intercept. Sometimes if you just fit a line, so it's going to be an error term. Okay, so this is what your normal regression equation. Okay, if you see the data which is available in this case, so age of a person, so first sample, so first patient, his age is 20, the age is 22 and the gender is a female and she is a non-smoker category, but in spite of that there is something called as disease status. If disease status is 1, then it shows that that person has got a disease. Okay, second person, so second person is the age of second sample is 25 and the gender is female and she is a smoker. So ideally what we feel, the smoker category people will have chances of getting some health problem. Okay, so that's why it has got health problem as one. Third category is male. Okay, so third person is a male and his age is 18. Though he is a smoker, because of some reasons he don't have any health problem, so it is showing as 0. So fourth person is 45 years age and the person is a male and he is a non-smoker. So though age is somewhat higher, there is no problem of smoking, so he don't have any health issues. So the disease is coming to be 0. The next person is age is 12 and the gender is female and she belongs to a smoker category. In spite of having a smoking category because of age or some thing, so she don't have any health problems. Okay, so this is what the data set. Is that clear, guys?
Yes,
Now,
sir.
yeah, now we'll just see a problem related to this one. So if I just talk about that y cap is a dependent variable and independent variables. So x1, as I told, x1 is independent variable, x2 is an independent variable, x3 is an independent variable, x4 is independent variable, xk is independent variable, and regression coefficients. If you see b1, b2, b3, b4, bk, so these are regression coefficients. Okay, so a normal linear regression will be predicting the values between minus infinity and plus infinity. Okay, so you will have values. So this, even if this probability is coming to these slides, you are going to get a regression trend line. So this is called a regression trend line or best fit line. But coming to the linear logistic regression, we will not have that as a line, but it's going to be an inverted S curve. So where the cutoff rate is going to be 0.5. So cutoff rate is 0.5. Whatever the values which are getting less than 0.5 will be treated as these values. Whatever the values which are going to get, which is more than 0.5, we are going to quote here. So that is what our logistic regression. Okay. So the probabilities we are trying to find out. So probability, if it is less than 0.5, we'll treat it as something. If greater than 0.5, we'll treat it as something. Okay. So now if you just see like the function for the logistic regression equation is f of z is equal to 1 divided by 1 plus e power minus z. So whatever the y cap function that we have seen, so this function will be completely replaced with minus z. So that is what logistic regression. We just see that one. So f of z is equal to 1 divided by 1 plus in e power minus. In the place of minus z, you can see the same thing. Okay, so that b1x1 plus b2x2 plus b3x3 plus up to so on bkxk plus a. So this is what your total normal linear regression equation. So that will be represented with 1 by 1 plus e power minus z. So if you just mention like that, it is going to be something like that. Okay. So the probability of y is equal to 1. So that means, as we have mentioned, y is equal to 0, y is equal to 1. So y is equal to 0 is no disease, and y is equal to 1 is it is disease. So this is what we have mentioned here. Okay, we just see the earlier in the table here we have seen if the condition is here. So if y is equal to 1 means disease, y is equal to 0 means no disease. So that is what my presentation here. So if y is equal to 1 is equal to 1 divided by 1 plus e power minus b1x1 b2x2 up to so on bkxk plus a. So this is what the equation for logistics and regression. Is that clear, ma'am? Is it fine? If it is fine, we'll just go to one problem. Okay, so if you see the differences between, so probability of diseased, so probability of, okay, so in the present function, as in the present problem we have mentioned, maybe age is one category to check the heart. Okay, the heart related disease, one factor is age, the second factor is gender, the third factor is smoking status. So using these three status, these three variables, how far you are going to get your heart disease. Okay, so heart disease might be 1 or 0. If it is 1, it is disease related thing. If it is 0, this is no disease related thing. Okay, so here you can see the age is just a number, and gender, in this gender you have two things. Okay, one might be male, the second might be female. Okay, and smoking, here there are two categories. Either the person is a smoker or the person is a non-smoker. Now we need to check, depending upon the age of a person, if it is a male and a smoker, what is the chance to get heart disease? Okay, okay, fine. Being a male, what is the chance that you are going to get a heart disease in spite of having a smoking thing? Okay, so assume that if you are a male non-smoker, what is the chance that you are going to get your heart disease? Okay, you are normally you are a female. Okay, and smoking habit is there. So what is the percentage of probability that you are going to get your heart disease? You are a female and you are a non-smoker. In that case, like what is the probability that you are going to get a heart disease? So this is what we are going to see in a problem. Okay, so you can see here the probability of disease is a function of age, it is a function of gender, it is a function of smoking status with the available details. Okay, I have got some data set which will be using that a maximum likelihood method. So using that, we'll trying to predict what are the chances for a particular male having some age. If it is a smoker, what is the chance that he's going to get a heart disease, or the second category, what is the chance that he's not going to get a heart disease? Okay, so and to just before starting that one, a simple one more example is there, because that as it is coming to be a multivariate analysis. Before that, I'm just have mentioned one graph here. The classification with the help of probability using logistic regression. Suppose we want to classify the result. Okay, so result is what our dependent variable. So result is our dependent variable in this case. Okay, and what is the function? Like it is a function of the using the number of hours studied. Okay, so number of hours studied. So normally we feel that if you study more hours, the chances of getting pass as a result is more. Okay, so this dependent variable have two categories, either pass category or fail category. Okay, so if you study more hours, either you can go to pass category or you can go to the fail category. Okay, so this is what the basic assumption here is. Only we are using one dependent variable, one independent variable. Okay, so this is usually shown in the figure, and as I already mentioned, using likelihood method. So this is what the number of hours studied. If you are studying number of hours in x-axis, and the result will be mentioned in y-axis. Okay, so if you study less number of hours, the chances of passing is very, very less. If you study more number of hours, the chances of passing is more, or there is less chances of failing here. Okay, so there are this we have taken 1, 2, 3, 4, 5, 6, 7, 8. So total 9 students are there in this example. So 3 students studied less hours. So studied less hours, so they got failed. So obviously that will be there. Only one student studied more, but he could not clear the exam. Okay, because if you see here, x is a function which is simply rising here or going upwards. So this is a person who studied more, but probably what he has written has not been correct. Maybe he has written something which is not relevant answer, so he got failed. But here, if you see, these are the students, 4 students who studied well and who got passing marks. But only one student, so in spite of studying less hours, he has scored good marks. Probably the topics which have been asked in exam, he might have studied in earlier class or something. So there might be some error also, but this is what the passing or failing category. Okay, so these are the probability for the people who are failing. And so these are probability for passing. Suppose if you get any particular new observation here, okay. So X is, assume that it is 5 hours, 10 hours, 15 hours, suppose 20 hours. If any person study 20 hours, definitely he'll pass in the exam, because higher the X value, higher will be probability of passing. So higher probability is there. So y also will be equal to 1. Suppose in the second category, this is figure 1b. So here, if you are trying to predict a person who studies only for 3 hours or 4 hours, the chances for that person is going to be more for failing in the exam. Is that clear? This is one variable input, so one input and one output case, where if you study more hours, definitely the chances of probability to get into pass will be more. If you study less hours, the chances of fail is more than passing. So this is what this one. And if you try to run a program, or if you try to run this as that one, so there is a sample of 14 students. First student studied 1.5 hours. The result is he failed because he could not study completely. He got failed. Second student studied 7 hours and he got passing marks. Okay. Third student studied just half an hour. Okay. He's very busy, not studying. So he also failed in this exam. And next student studied 9 hours. As higher the hours studied, obviously the chances of probability will be more towards 1. So he got cleared the exam. Next student studied 8 hours. So he also passed in the exam. Next student only 2 hours. So he also failed in the exam. If we just see the total data, the people who studied more than 5 hours, so more than 5 hours are having a result of pass. The people who studied less than 5 hours, the people who studied less than 5 hours are in towards the failing in the exam. Okay, so this is one of the SPSS outputs, and I believe you are quite okay or aware of SPSS, and even sir also told me that. So out of these 14 cases, missing cases are 0, total is 14, and unselected cases 0, and total cases are 14. So original value 0 and internal value 0. So this is some block 0 beginning. So when you're trying to check something about logistic binary prediction in logistic regression, there is no need to consider much about beginning block, because once you run the program, it will simply tell, it will simply give along with the output. But I just purposefully shown this to not to give priority for that one, because this simply assumes independent variable, dependent variable are not so concerned, and it automatically runs and gives some prediction. But this is what important in this case. Okay. So the variable not in equation. So block 1 method is equal to enter. So this is what very important. And here we are going to see something. So here we are going to see something. We will get different chi-square values. Okay. I hope you have, and this chi-square values, all the three are showing significance. And this particular table will simply tell that there is a difference between block 0 and block 1. If you don't consider any relationship between independent and dependent, that also will give some number. But if you consider a relation between independent and dependent, so that will be given by block 1. And there is a significant difference between these two values. Okay, so that is what the significance values here. Okay, and model summary, but I've seen R square. So normally R square is coefficient of determination. Okay, so it tells about how effectively your independent variable, how your independent variable is explaining the variation in a dependent variable. Okay, in dependent variable. So explanation power. So how independent variable is explaining the dependency in the variation for the dependent variable. So explaining the variation and dependent variable. So higher the R square, higher will be explanation power of independent variable or varying of dependent variable. So here, if you see this, as this is a logistic regression, it talks about likelihood method, okay, instead of normal thing. So here you can see Cox and Snell R square and Nagelke R square. So these are two other measures, and this Nagelke measure, it's telling 1. So that means 100% of variance of dependent variable is explained by independent variable. And this Cox and Snell method is telling that 75%, so 74.5% of variation, 74.5% variation in a dependent variable is explained by our independent variable. That means the results is a dependent variable. That results has been explained 75%, almost 74.5% with the help of our number of hours studied. Okay. But the second method, which has given 1.00, it is completely explaining that one. Whatever the results are there, it is completely due to this number of hours studied. So this is what in this case. Okay. And coming to the actual case of output. So this is what the logistic regression. Yeah. So this is what related to our heart disease related. One variable input. Is that clear, guys, with you? If it is clear, I'll try to run the SPSS output for this problem. Is that fine, or anyone has got any doubt? Okay, so there is only one person, Soma ma'am. So can you just run the output in SPSS, or do you want any explanation? Okay, so this is what the data for the practice. Okay, I hope you can see the screen here. And
Yes.
yeah, so disease data set. Okay, so this is the data set of that one. So disease is a dependent variable, age, gender, smoker status. So these are three independent variables. And the first person is a diseased person, age is 43, gender is male, smoker category. Okay, second person, not diseased, age is 18, male, a smoker. So if you see that one, maybe 10th person, I'm just randomly selecting people. This person is not deceased, okay, and age is 27 years, male, and non-smoker category. So like that, you have got data of totally. And if I just try to see what is the total number of people, so 37. If I just remove the heading, the first row, there are 36 patients, so 36 people data is observed here. So ranging age between different ages. Okay, so from 10 to 90 years, because you can see 23, the number here. So diseased person, because it is 88, obviously the body functionality will come down most of the cases. Because of that, he is a diseased person. So like that, and the smoker category will be definitely, even the age is less, he might be diseased or not diseased. So as this is what the basic data, and I've coded this into disease as 0 and not diseased as 1. Okay, so diseased as 1 and not diseased as 0. Okay, so that is what this data. Okay, so if disease is there, so I have mentioned it as 1, and the second person is not diseased, so I have mentioned it as 0. And age I did not change. And coming to the gender, male, the first two people are male, third is female. So male has been given 1 and female has been given number 2. Okay, so this is what the basic representation which I have made. And for smoker category, I have given 1, and non-smoker category, I have given 2. Okay, so this is not an issue. Either you can give 1 and 2, 1 and 0, 0 and 1, 0, 1 and 0, something like that. Okay, you can code the data. So once your coding of data is done, so then you can run the program with SPSS, because I believe most of you are working with SPSS. So I just wanted to show that one. So you can just pull the data from your, like, where exactly the location of the data. So the data I have mentioned in my desktop, logistic regression. So since that is Excel file, I have to select like which format of file I'm just doing. So logistics regression I'm opening. So this is what data for practice, which I have to just see. So I've selected the data practice and opening that one. So it is asking A1 to D37. So it is showing the worksheet. I'm clicking S. So once I've clicked S, so it will show like what exactly there is. If I see my data view, it has taken 143. So only age I did not change. Okay, remaining things I've coded and decoded. So here disease is 1. Non-disease has been become 0. So I have to change that variable names also. So this is usual, and I have to just make this numeric, and here I have to give the values. Okay, so here I'm just mentioning disease. So this is what the label which I put. And coming to here, so 1 is called as disease, DISEAC. So I'm defining that one. And 0, I have mentioned no disease. So this is no disease. Okay, so I'm just clicking OK. So now if I just click that one, I can see both the variables. It's like 0 and 1. And age, I'm not changing anything. And gender, as I already told, I have given 1 for male, and I've given 2 for female. because whatever the coding which I've given, I'm just using that code here. I'm clicking OK. And smoking category. So 1 for smoker. So smokers are categorized and are labeled as 1, and non-smoker have been mentioned as this one. So this is non-smoker. Okay, so this is what I've given. So right. So now as this is done, I have to just check, analyze, and I've just go to a regression. So in regression, as I'm trying to find out that logistic regression, you can just go to that binary logistics here. Okay, so here you have to just click so that you'll see that value. So out of disease, age, gender, and smoking status, my dependent variable is disease. Okay, I'm just trying to find out how far the disease is dependent on age, gender, and my smoking status. So I'm just clicking disease, which is a dependent variable. And the remaining variables, like so independent variables have been categorized as covariates. I need to find out whether age is, how far age is related, how far gender is related, how far smoking status is related. Okay, so these are the three independent variables. And out of these three variables, I need to check like what are categorical variables. Okay, so I'm just clicking this one. So out of these two, gender and smoking status are categorical variables. So I'm pushing those into categorical and I'm clicking this one. Okay, so coming to the next one, I need to check what is the probability of getting these male, female into that health related category. And coming to the options, I'm clicking classification plots and Hausmeyer, and here confidence interval. Okay, so I'm just clicking these also so that I'll see what exactly is my output. Okay, so I'm just clicking that one. So this is what the output which I got. So logistics regression and selected cases 36, because I have already shown I have taken 36 sample and there is no missing case here. There is total 36. Okay. So here the dependent variable, I have defined a dependent variable as no disease as 0, diseases case as 1, and categorical variables codings. So as I have mentioned, my coding as smoking, I have mentioned as 1, non-smoker as 0, gender male as 1 and female as 2, and the frequency, like how many, the frequency here, there are totally 20 smokers in the total database and 16 non-smokers. Out of 36, 20 are smokers and 16 are non-smokers. And out of 36, 23 are male and 13 are female category. Okay. So as I told, this block 0 beginning will be some kind of representation which assumes no value or no relation between dependent and independent. So this is only for the namesake, and you can just check block 1. So there will be certain, yeah, at 95% you can see there is a change between block 1 and block 0. So block 0 and block 1. So significance is 0.32, 0.32, 0.32. And model summary. So for likelihood is 40%. So mostly 40% is completely likely for this. And 0.217 is Snell. The 21% of variation or 21% of a dependent variable is explained by our three independent variables. And coming to the Nagelker R square, it is 29% or 0.29%. Okay. So next you can see this is a chi-square expectation, like observed frequency and expected frequency. So disease, no disease, disease, disease. If you just see the next table, yeah, this is what the important table which you need to check. So observed values, no disease, and predicted values, no disease. So if you just go through in this case, like no disease and no disease is 11, and no disease and disease, we have predicted wrongly 5, and the percentage of correct prediction is 68.8. Out of 16, 11 has been predicted correct and 5 has been predicted incorrect, the model which we have created. And so coming to the disease related, so a person has got disease, but it has assumed 5 as no disease. That means there is some error in the prediction, and disease people got predicted as 15. That means out of 20 disease people, 5 has been mentioned as no disease and 15 have been mentioned as disease. That means here the accuracy is 75%. We have predicted correct. Overall accuracy is 72.2. And so this is what the variables in the equation that we have got. Okay, so age, so this is quite important. So this 0.43 is related to B1 and 0.87 is B2, 1.337 is B3, and this constant is A value. Okay, and if you see all this, none of the values is significant in this case. 0.09, 0.28, 0.08, 0.03. Only constant is more significant in this case. Okay, if you just go back to our normal slide, I'll try to explain this here. Okay, so whatever we have predicted the values in this case, so out of 36 values, so what we have assumed is, so this is what the dependent variable encoding. So no disease has been coded as 0 and disease has been coded as 1. And coming to categorical variables, so I've mentioned smoking status and gender as categorical variables. So there are 20 smokers, there are 16 non-smokers. There are 23 male and there are 13 female, because if you just add this is going to be 36 and this is going to be 36, because the total data that we have taken is 36. Okay, and as I mentioned, likelihood related and 21.7% is explanation power of independent variable or the dependent variables. Okay, so this is 29%. The model is not so robust, not so efficient, but this has been given by SPSS. Fine. So here, if you see, this is what observed values. So this is what actual values, and this is what are predicted values. Okay. There are people, no disease people are totally 16. No disease people are totally 16. Disease people are 20. Okay, so this 20 out of this 20, our model could able to produce 15 correctly as disease people. Okay, 5 incorrectly as no disease. Though the people have disease, as we basic assumption like less age. So if age is less, we assume to be no heart disease. Okay, so this is what the basic assumption, and even the model also assumed like that. Because of that, there is some error. And here, no disease people totally 16, and it has predicted 11 as no disease. Okay. There are some people, like 5 people, have been incorrectly predicted as no disease, though, so disease, even though they don't have any disease. Suppose there might be a person who is some 80 years age. If he is having a good exercise daily routine, probably he might not be having a disease. But by seeing this age number, probably we feel that aged people might have this heart disease, that might have a problem. Okay, so this is what. So out of this percentage is telling, out of 16, so 11 has been correctly predicted and 5 is errorly predicted. So this is error percentage. This is correct prediction. So out of 20 in the second related case, so 15 has been corrected correctly, 5 has been predicted incorrectly. So, and if you see this model, so 0 0.43, 0 0.87, 1.337, this one. And so this is B1, this is B2, this is B3, and this is a constant value. Okay. And if you see a significance, so this is not significantly impacting the heart disease, age factor, and gender factor is also not significantly impacting the heart disease problem, and smoking status also not significantly impacting this heart disease problem. Only this is impacting a highest value. Okay, because as we are checking about 95% confidence level, alpha is 0.05. In only one case, your significance value is less than this one. All the 3 cases are having no significance pattern. Okay. So if you, as I've just mentioned, probability, as I've just mentioned, the probability of calculation y is equal to, so 1 divided by 1 plus e power minus b1 into h plus, so this is minus, so b2 into gender plus b3 into smoking status plus a. Okay, if I just see these values, 1 divided by 1 plus e power minus, what is my b1 value? As I've mentioned, is 0.043 multiplied by age. Suppose a 55-year age person plus b2 is 0.87 from the table multiplied by gender maybe 1. Okay, so male assume. Okay, so plus b3 is 1.337 multiplied by smoking status, no smoker, assume it to be 1. Oh, sorry, no smoker is assumed to be 2. So minus 2.729. If you try to find out value for this, you will get either 0 or 1. Okay, so based on probability of 0.72, 0.36 something. Okay, so if you just try to use that one, you are going to get whether the new category. So we have since 36 variables, okay, 36 observations. There is a 37th observation with 55 years and a male with non-smoking category, whether he will have disease or not, maybe yes or no. So this depends upon your probability. Once you try to find out this value, it may be either, if it is 0.8, so then it is going to be 1. If it is 0.3, then it is going to be 0. So that is what your logistic regression. Is that clear? And if you just see this value, I have got some comparison also. Okay, so prediction comparison. So this is what the actual values and prediction. So once you see these particular values, so using that one, if I just try to compare this one. So as this is B1 value, this is B2 value, this is B3 value, this is A value. Anyone would like to speak? Sir, anything that you would like to tell, sir? Okay, fine. So this is what are based on from this table. I have copied B1 value, B2 value, B3 value, and A value. Okay, so and if I just try to multiply B1, so here I'll be sharing this sheet also to Farah ma'am so that she can share this to the students. So here, if I multiply B1 with age, so this is going to be 1.834. Okay. B2 with gender, so it is coming to be 0.87. B3 with smoking status, it is coming to be 1.337. Okay. And minus A value. Sum of all these values is 1.1327. And as I wanted to find out exponential value of negative of all these things, okay, so it is coming to be 0.26527. Okay, so if I input that in this function, 1 divided by 1 plus these values, it is going to be this particular, the final 1 divided by this value is this, the final value is 0.79. If it is 0.79, as it is more than 0.5, it will give a value as 1. Okay, so this has taken, it has so 1. If you try to drag this to the last, you'll get everything, and this is what the prediction. Okay, this is the predicted value, and this is the actual observed value. And I've just run a simple code to check whether how far my prediction is correct or not. So first category, actual observed value is error, and my predicted also error, predicted also disease. So there is no error. Second category, the person don't have any disease. But with my calculation, I got a smoking status and something. It assumed it to be a disease. So this is an error. If I just add all these errors, I got total number of errors as 10. Okay, so no error category are 26. So this is what, if we just go back to our original our slides, you can see. So this 5 is an error and this 5 is an error. So 10 cases have become error. So that is what you can see in this Excel sheet. Okay, so this is what errors and this is what no errors. Fine. So I've got a couple of problems, so probably which are not solved. I'll be able to share that to Farah ma'am so that she can be sharing that to the learners. Okay, so from my side, this is what from my side. So thanks a lot for your patience, Soma ma'am, and as usual, Dibdra Datta sir and Farah ma'am. So thanks a lot. Now I'm open for any queries or doubts.
Sir, I like to share. I am very much happy to say that is Rita Publication just now has informed that is they are ready to publish our book.
Oh, congrats, sir. Thanks a lot. Congratulations, sir.
Okay. And they have requested, sir, the Word document so
Okay,
that
please,
they
sir.
can start the work.
Sure, sir.
Because whatever the document you have shown,
It is a PDF.
you have given that is the PDF file.
Yes, sir.
So
Yes, sir.
please you give me the Word document.
Sure, sir.
They will start editing.
Oh,
And their own problem, that is there is some scan image, and
Okay.
that scan image will be the gray in color.
Okay.
Is it okay?
Yes, sir. It's okay, sir. No problem. But anyhow, I'll be sharing that Word file. Either
Yeah.
they can check if they can do anything. Probably they can do that. Otherwise, even gray image also not a problem, sir.
Okay, okay, okay. Thank you.
Oh, thank
And
you
sir, you
very
have
much, sir.
taught our students very nicely with
Thank-
all the formula equations and everything. And you have used SPSS also, even the Excel also, MS
Yeah.
Excel, SPSS, everything you have taught. We are giving much importance on Art Studio.
Okay.
So I hope that is in near future, we will train them, the
Yes, sir.
Art Studio also for the logistic regression.
Yes, sir. Yes, sir.
Okay, now, dear students, if you have any question, please you ask, sir.
No, sir, I don't have any question at present moment. Thank you so much.
Okay,
Welcome.
so the students are happy.
Thank you, sir.
Yes.
Sir, you have taught them very nicely, and they will follow your lecture through the YouTube video,
Okay.
so that if there is any confusion, they will raise the question. I hope we will be able to satisfy them.
Definitely, sir. So sure, sir.
And it is my pleasure again to say that is our statistics books that is going to be published by the Rita Publication. This is a very common name among the students.
Okay, sir.
Yeah. So
Congratulations, sir.
thank you.
Yes, sir.
And
Congrats.
please you congratulate Naresh sir, because Naresh sir has done everything. Though
Yes,
I
sir.
have guided, but Naresh Babu has done everything. We are grateful to Naresh Babu sir.
Thanks a lot, sir. Because with your inspiration only we have started, sir. And whatever the files that I've shared, you have given right input and you made me to learn a lot. Because of you only, I'm teaching statistics today. So this is what I can. Even I used to tell that to Madhumita ma'am and Sharma sir also. And I'm appearing for NPTEL exams, and without preparation, I'm straight away going and I'm getting 90 marks in it.
Okay, thank you, sir. In future, we will send our students to ABBS so that they will learn many things.
Definitely, sure, sir. And I'm learning many things from you. So I'm thankful to you for that.
Please you convey it, Madhumita madam.
Sure,
and
sir,
I will
definitely.
also do it.
Yes, sir.
But before that, I have to take their assurance. They will send me the email.
Okay, sir. Okay, sir.
That is, they have accepted for
Okay.
publication.
Okay, sir.
Okay.
Sir. Thanks a lot, sir.
Thank you, sir. Thank you.
Yeah. Thank you, Farah ma'am. Thank you, Soma ma'am. So thanks a lot. Have a
Thank you,
nice.
sir.
Yeah.
Regards.
Yeah. And Farah ma'am, I'll be sharing this Word file, Excel file, PPTs, and or SPSS files also to you, ma'am. Okay. Okay, sir. So thank you, sir. Good night, sir.
Okay. Thank you.
Okay, sir.